In the sketch, the following functions are represented. F of x equal to 3 to the power of x. Is that x? Yes. 3 to the power of x. G of x, the reflection of f in the line y equal to x. That means it's an inverse of f. H of x, the reflection of g in the x-axis, right? Determine the equations of g and h in the form y, right? Let's get to that. So 8.1, determine the defining equations of g and h in the form y, right? So we know that f of x is 3 to the power of x, and we know that g of x is the inverse of f, right? So g of x, if it's the inverse of f, it means it's just log x base 3, just like that. And they said in the form y, so you can just rewrite this as log x base 3, right? So our h now is a reflection of g about x. So this means h of x is equal to minus g of x. What does this mean? It means that h of x is equal to minus log x base 3. And this can be rewritten as h of x is equal to log x base 1 over 3. This is because of the law that log 1 over a, log x1 over a is equal to minus log x base a. This is the law. If you remember the log properties. So if you remember the log properties, this is what it means. So we use this log property. So in other words, so we can just say y is equal to log x base 1 over 3. 8.1.2, determine with the aid of the above sketch the values of x for which f of x is greater than 0. Now let's look at that. So we're looking for where f of x is greater than g of x. So now let's look at f. So this is f. This is our f function, and this is our g function. So from this point going that side, you can see that although f is above, but g is not available when x is negative. So it means we cannot include this part. So this part cannot be included. And then when x is equal to 0, again, g does not touch 0. So it means also x equal to 0 is excluded. So we can only see that f is truly above g only when x is greater than 0. And that's our answer. So f is greater than g when x is positive, not when x is greater than or equal to 0, because we see that when x is equal to 0, g does not exist. So we are only looking at where both graphs exist. And in this case, they both exist when x is positive, and f is greater than g when x is positive. And just like that. So for b, we are looking for the x values where g of x divided by h of x is equal to 1. Right. So someone here might say, oh, we're looking for the division of the two. So in other words, we want to take this and divide this, take this and divide this, and like that. Well, although that may work in certain circumstances, if you take this and divide it by this, you are going to get a negative 1, because it's positive divided by negative, positive divided by negative, and stuff like that. And then someone might say, okay, when we get to this point, this is 0 divided by 0. You see what's going on here? So this produces complexity. So the easiest way to solve this problem is you are going to rewrite it in a way that you are going to understand. So we have g of x being equal to h of x, which is being divided by h of x, sorry, and they are all equal to 1. So what we can do is we can remove this h of x at the denominator. So we can cross multiply this with that. So in other words, so this will become g of x being equal to h of x. So now our question changes to where is our x value where g of x is equal to h of x. So we're looking for the point of intersection. So we see that they intersect when x is equal to 1. So x is equal to 1 is the answer. If you were to divide these two, you would have gotten a math error, because when you divide 0 by 0, then you get a math error. But this helped us to actually see that we can rewrite it in a way that is going to be understandable.